All right, so we continue with our physics, 54, revision. If you're doing pure science, this is a good question for you. This is what you're going to find. So this is on the topic called pressure. So it says the figure below shows a solid cylinder of mass 200 kg immersed in water in a rectangular transparent tank. The cylinder has a cross-section area of 0.5 square centimeters. So that's the cylinder, solid cylinder, and it has a height of 80 centimeters. It is placed 40 centimeters below the water surface, and it is held vertically in position by two ropes. The rectangular tank has a height of 160. So the height of this rectangular tank 160. Then you can see these are the ropes holding it on top and at the bottom. Then the height of the solid cylinder 80. Then from the top to the top part of the cylinder, that is 40 centimeter. Then it says the density of water is 1000 kg and gravity is that which they have given us. Then it says state Archimedes' principle. So Archimedes' principle, the principle states that a body immersed in a fluid. When we say a fluid, it could either be water or gas. So a body immersed in a fluid experiences an upthrust. So experiences an upthrust equal to the weight of the fluid displaced. So this is what Archimedes' principle actually tells us. So a body immersed in a fluid experiences an upthrust equal to the weight of the fluid displaced. In other words, the upthrust is equal to weight of fluid displaced. That is what this law, according to Archimedes' principle, actually states. So you need to remember it. It's actually a very important principle, especially if you're doing pure science. Then B says calculate the pressure due to the water. So it is due to the water at the top of the cylinder. So at the top of the cylinder, due to the water. So remember, pressure in a fluid is given by the density rho p, the height, and gravity. So they have given us the density of the water is 1000 kg per cubic meter. So this is the data that we have. And then 2, we know the gravity is equal to 10 newtons per kg. Then what we need to know is the height. Since they say at the top the depth is 40 centimeters. So 40 centimeters right away, divide by 100, and that will give you 0.4 meters. So pressure be the density, which is 1000 kg per cubic meter, times the height, which is 0.4 meters, times gravity, which is 10 newtons per kg. So when you multiply that, is going to give us this, and that will give us 4 times that will give us 4000 Pascal. Or if you want, you can simply say 4000 newtons per square meter. There's no problem with that. So that's the pressure at the top. What about the bottom? In this case, how do we calculate? It's the same. Now in this case, the height that we are going to use, since at the bottom it will be 40 centimeters plus 80 centimeters, which is going to give me 120 centimeters. But right away, I'll divide by 100 to convert to meters, which will give me 1.2 meters. So pressure is equal to rho p, the density of the water, the height or depth. So this is the height or the depth. That's what you need to remember, times the gravity. So it will be 1000 kg per cubic meter times the height, which is 1.2 meters, times gravity 10 newtons per kg. So if you multiply, this will be 12. So that will give me 12,000 in this case 12,000 Pascal, or if you want, newtons per kg. So that's the pressure, the pressure at the bottom, and this is on the top there. So this is what they wanted you to do there. Now notice the other questions that they gave you in line with that one. It says that calculate the force due to the water pressure exerted on the top of the cylinder. So how do we calculate the force due to the water? So according to the formula, pressure is equal to force divided by area. If we make F the subject of the formula, force is equal to the pressure times the area. So the force at the top will be equal to the pressure at the top, which we got. What was the pressure at the top? It was 4,000. So it is going to be simply 4,000 Pascal times the area of the cylinder was simply, remember they gave us the area 0.5 square meter. If you didn't take note of it, this is the area of the cross-section area of the solid cylinder. It was 0.5. So we are just going to be multiplying 4,000 times 0.5 square meter in this case. So what is that going to give us in this case? So it is 4,000 times 0.5, and that is simply going to give you 2,000 newtons. So that's the force on top. What about if you look at the force at the bottom? Well, again, the force at the bottom will be equal to the pressure at the bottom times the area. So the pressure at the bottom, if you still remember, was 12,000. So it is going to be 12,000 times the cross-section area, 0.5 square centimeter. So it will be 12,000 multiplied by 0.5, which will give us simply 6,000 newtons. So that's the force that is exerted at the bottom in this case. Then the question there was saying, will the cylinder float, sink, or rise when the ropes are removed? Show your reasoning. So they want you to show your reasoning. So of course, just by looking at the forces, I can tell that the force, at the top is actually less than the force at the bottom. The force at the bottom is greater, and based on this assumption that we have there from the calculation we have done, we can see that it is actually going to rise because there's more force at the bottom than at the top. But it says show your reasoning, and this question was carrying 3 marks in the exam. So let's try to see basically what you could have actually done using Archimedes' principle that we have learned. So one, I could have actually looked at first of all, the weight of the cylinder. So the weight of the cylinder given by mass times gravity would have been 2. They gave us the mass of the cylinder, which was simply 200. So it would have been 200 kg times gravity, which is 10. So this would have given me 2,000 newtons. So that's the weight of the cylinder to start with. Then the next thing, since we know that upthrust represented by a symbol mu is equal to the weight of displaced is equal to the weight of the displaced water or the fluid that we do have. So we could have simply now calculated, having this concept in mind, we could actually say that then the volume of, we can calculate the volume of the cylinder. The volume of the cylinder will be the area multiplied by the height. So if you look at the area times the area is 0.5 square centimeter times the height of the cylinder alone. The height of the cylinder alone was simply 80 centimeter, if you remember. So 80 centimeter divided by 100, that is 0.8 meters. So when we multiply the two, 0.5 times 0.8, this is simply going to give me 0.40, and that would be in cubic centimeter. So that's the volume of the cylinder. Now if you know the volume of the cylinder, you can now calculate the mass of the displaced water. So how do we calculate now mass? Remember it says show your working. So mass of displaced water, sorry my space is limited, mass of displaced water will be equal to density times volume. Where am I getting this? Remember, density is equal to mass divided by volume. So therefore, if you make mass the subject of the formula there, by cross multiplying it to be rho P times V. So that's why mass times density. So mass of the displaced water, the density of the water is 1000, and the volume is equal, the volume of the cylinder will be equal to the volume of the water that has been displaced, which is equal to 0.40. So when we multiply that, it will give me 400 kg. Now if I find that, we can then find the weight of the displaced, we could find the weight of the displaced water. The weight of the displaced water is simply mass times gravity. So we'll get this mass, which is 400 times 10, and that is going to give us 4000 newtons. So this is actually the weight of the displaced water. Now if this is the weight of the displaced water, the weight of the displaced water is equal to the upthrust. Sorry, I'll use just this space there. So the upthrust, which is equal to the weight of the water, is equal to simply 4000 newtons. That's what we have found from there. So that is equal to. Now if you look at what was the weight of the cylinder, the weight of the cylinder is simply 2000. So if you notice the upthrust represented by this, sorry, this is the symbol for upthrust. The upthrust is actually greater than the weight of the cylinder. So because the upthrust is greater than the weight of the cylinder, it simply means that the cylinder will rise. So it is actually going to rise. That's the conclusion. So remember, it also from the forces you would have actually concluded that it is possible. There are so many ways. You said the force at the top is less than the force at the bottom, or if you want, you would have said the force at the bottom is actually greater than the force at the top. And based on that conclusion, when the ropes are cut, it simply means that the cylinder is going to rise. So you should be able to do this gymnastic. Watch out some other videos and some other series in my pure section, then you'll be able to benefit. Let's conclude with this one there. It says the figure below shows one of the forms of an apparatus used to observe Brownian motion of smoke particles in air. Looking through the microscope, sees tiny bright specks which describes as dancing about. So that's what they have actually seen. So this is the experiment to observe the Brownian motion. This is a smoke cell, and inside of it there's actually smoke. Then they tell you then light is actually shown magnified so that you are able to shine, or using a converging lens to converge at a particular point so that you are able to see what is happening there. Now the question says, what are the bright specks? So in here there are smoke particles, but of course remember that there's also air molecules in there. In as much as there's smoke, there's also air that is there. So the bright specks are the smoke particles. So we can simply say that they are smoke particles. And those are actually smoke particles. They are actually illuminated by light. So they have actually been shown by light. So the smoke particles have been illuminated. No wonder they appear as bright specks. So why are the specks dancing about? Why are the smoke particles, in other words, dancing about? The reason is that we can simply say because they are continuously, so use the word, they are continuously bombarded. So they are continuously bombarded by fast moving air molecules. So they are air molecules. The air molecules are always moving. So because they are continuously bombarded by fast moving air molecules, no wonder they are seen as dancing about. So it says, state the conclusion that can be drawn from the Brownian. So what conclusion can we make there? So the conclusion is that we can simply say that molecules of air or liquid, or if you want, you could have said molecules of a fluid. A fluid can either be a gas a liquid. So molecules of air are in constant, so we can say they're in constant random motion. Yeah, and what does this tell us? Well, this actually provides, evidence. So it actually provides evidence, for the kinetic, for the kinetic theory of matter, which tells us that matter is made up of tiny particles, and these tiny particles are in continuous random motion. So thank you so much for watching. In case you missed where we started from because the video cut, please, you can actually watch out and see that, especially if you're doing pure science, this is actually a good question. For those of you that are doing science, the ordinary science, question number 2 and even the last one are good questions that you can actually look at, and also question number 3. Thank you so much for watching. If you enjoy what we do, you can hit that subscribe button so that you can continue to receive notification for new videos.